So welcome to the 7th session of our conference, Smart and Sustainable Systems, Innovation in Energy, Data and Connectivity, where we will explore innovative solutions for sustainable power generation, advancements in digital infrastructure and analytics, and emerging models in transportation and vehicular communication, all alongside the crucial role of capacity building in strengthening research and education networks. Our speakers join us from leading institutions and industries worldwide, each bringing valuable insight from both research and practice. Without further delay, let us begin our session. I invite our first speaker, Dr. Ahmed Kabeel from Delta University for Science and Technology. Please. Should we clap for him, please?
Assalamu alaikum. Good evening, everyone. I will present today our research titled with Design and Analysis of Hybrid Solar RF Energy Harvesting System for Sustainable Power Generation. My name is Dr. Ahmed Kabeel. I'm an assistant professor in Delta University at the Faculty of Engineering. I'm a vice director of International Ranked Center, ambassador for YASIS, and IEEE ABS MTTS secretary in Egypt. Our Delta University has ranked appear in many rankings like US, ARU, THE, and our location is in the northern coast in Egypt. Let's start with our agenda. We will discuss the energy harvesting, third, then how to use antenna in energy harvesting, then combining solar cell with antenna and study, and we use transparent antenna in order to combine it with the solar cell. Then we study the mutual effect of solar cell and antenna on each other. Then we move on conclusion and future work and question. Let's start with the term of energy harvesting. Energy harvesting is a process of scavenging energy from any physical source to convert it to usable power. We have the light energy or kinetic or thermal energy, and nowadays we will interested in RF or radio frequency energy harvesting. Well, everybody know about solar energy harvesting. Solar cell, electrical device that convert the energy light directly from the sun. But we need to know what is RF energy harvesting. RF energy harvesting is radio frequency energy harvesting. It's an energy conversion technique to employ to convert the energy from electromagnetic sources into an electrical domain. Electromagnetic sources may be information or energy. We call it RF wave source. In particular, RF energy harvesting, very applied solution to use in low power application and IoT system. In order to make an energy harvesting system, we looked to the block diagram. We need a receiving antenna. We need a rectifier to convert the AC signal to DC signal, but we need in between an impedance matching circuit to prevent losses. The very early trial of wireless was by Tesla, known as aka Tesla Tower. It doesn't work, but nowadays the research direction focus on prototype and receiver architecture, wireless energy transfer source, different network architecture, and optimal resource allocation like time, frequency, power. RF energy harvesting design procedure, we need first to select the bandwidths we work in. Local survey for use bandwidth frequency and band usage and allocation. Then the design of antenna. Here we use a microstrip patch antenna, patch shape selection and the analysis. We need design and simulation and antenna array. Then the circuit design. like combiner, rectifier, matching circuit. Then the final step, fabrication, testing, and assembly. Here we have using antenna for energy harvesting. If we look at the first figure, we see the source, then antenna, matching impedance, rectifier, power management, then the application. But in the first figure, we use only single element antenna to collect the RF. But if we need to use a multiple antenna and we call it an array, we will face a problem. The first problem, we need a rectifier and a matching circuit for each element. So how we can prevent this? We use a power combiner to prevent each matching circuit and multiple rectifier for each antenna. Antenna over solar cell. Let's see the construction, the patch, then the perspex, feed line, and glass to prevent the mismatch between solar cell and antenna, then the SMA connector to feed the antenna. Combining it together, we use semiconductor which are not ideal substrate for antenna to do the variable conductivity. So we build antenna around solar cell, or we make a meshed antenna. This is combining solar cell with antennas. This is the figure. Then if we make a meshed antenna, it will reduce the transparency that reach the solar cell. So what is the other option? The other option is transparent antenna. Transparent antenna could achieve by using transparent conductive material like graphene, carbon nanotube, transparent conductive oxide, TCO, conductive polymer, nanowire, and these figures show the transparent antenna. Here is a transparency equation, or the relationship between transparency and thickness. We can see it's an exponential decay. It means when the thicker antenna get, the decrease appear on transparency. So we need to select the sheet with the same unit as resistance. It's ohm per square, and sheet resistance is determined by the material, so we can change in material, but we can change in the thickness. Let's see the effect of transparency antenna on gain. Let's know first what's the antenna gain. Antenna gain is the measure of antenna directivity and radiation efficiency, and its term has been duplicated by IEEE as shown as figure. Let's see the effect of transparency on antenna gain. For a fixed line width, we have higher transparency result a gain reduction. However, when fixing the transparency and optimize for line width, it's noticeable that the relation between antenna gain and width is inversely proportional. For effect of solar on antenna, when solar are placed near antenna, they cause interference and decrease the performance of the antenna, and the presence of solar cell are also lead change in the radiation shape. The most noticeable reduction in antenna gain occur when conductivity level where solar panel junction operate. Let's see the vice versa, the effect of antenna on solar cell. Solar cell efficiency is very sensitive to the attenuation in solar energy. Addition, any material over solar cell increase. We can see in the figure the power with voltage, where bare cell cover glass with antenna in 5 gigahertz and in 10 gigahertz. This a comparison with the efficiency between bare glass cover and patch antenna in 5 gigahertz and 10 gigahertz. This comparison integrate solar antenna energy harvesting designs with other research. Conclusion, transparency antenna allows sunlight to reach cell with a very low efficiency reduction. The use of transparent antenna eliminates the need separate structure for antenna. Combining antenna with solar cell enable dual function. Future work. Before future work, we noticed that the mutual effect between antenna and solar cell is decreasing each other efficiency, but in research we say bad result is also a result. For future work, we can study more transparency material or using a conductive ink to make an antenna. Thank you, and any questions?
Assalamu alaikum. First of all, thank you for this informative talk. I just have two questions. I'm not going to say concerns because still we don't have answers for these questions. The first one is, I think you did not mention about the methodology that you used, the formalism of the problem. How did you formulate the problem? Because we are talking about optimization of problem, and as we know, the solution of such kind of problems, it should be mentioned earlier in the formalism of this novel work. Honestly, the contribution of the paper or of this talk is clear, but I'm talking about the formalism as the first concern. The second one, can I ask you about the optimization solution? I mean, the algorithms that's being used in order to reach to such results, and also then you demonstrated these results. So, just these questions, methodology and the optimization technique that being used. Thank you.
I will answer the two questions in one answer. In antenna, we use a software called CST to design the antenna. On solar cell, we use console. Till now, there is no such software combined to design antenna and solar cell together. So we use the fabrication. We fabricate antenna on المركز القومي للبحوث الإلكترونية في القاهرة. And we combine it with a solar cell and we study it on actual.
Did you mean that you got these results based on real experiments in the lab itself?
Only fabrication.
Oh, fabrication.
There is no
no algorithms being used.
We intend to create an equation that describes a mutual effect, yes. So we can reach a software that combines the CST with console.
Okay. So because this is why, because we are talking about very critical and sensitive honesty problem when we're talking about the optimization. So I know it's not easy to do such a great work like this. But if you want to publish such work, we have to mention about the methodology and also the flowchart in order to show how the system will perform till you reach to the results and then the demonstration part. Thank you so much.
Thank you for your advice.
Thank you.
Thank you for your attention.
Thank you, Dr. Ahmed. We now invite Mr. Ahmed Abou Alam from Nokia.
Good afternoon, everyone. My name is Ahmed Abou Alam. I'm an IP networks consulting engineer at Nokia. I'm honored to be with you today to present you how do you eat an elephant flow. But before I start, I'd like first to give you a brief on what is an elephant flow. So a flow in the context of networks, IP networks, is a sequence of data packets that have common characteristics, and accordingly, these packets are treated as a single stream when being routed. Common characteristics, like what we call in networks the 5-tuple, which in very basic words are the source IP address, destination IP address, source port, destination port, and protocol, if you hear about the TCP and UDP. So these common characteristics, when they are common, when a flow has common characteristics, when packets have common characteristics, they are treated as a flow. So what is an elephant flow? It is still a flow, but it is a flow that consumes a significant amount of the network capacity. relative to other flow. Let me give you an example. Streaming an HD movie is considered an elephant flow when compared to consuming Twitter or X. Let's relate this concept of elephant flows to research and education networks. The first example I have today is the LHC, or the Large Hadron Collider, which is basically a device that accelerates particles and collides them at near the speed of light. And it is used within the European Nuclear Research Organization for experimentation. These experiments actually generate hundreds of terabytes of data. Another example is the Square Kilometer Array, or SKA. SKA is going to be the largest telescope in the world when the project is complete in 2028. It will have a site in South Africa that is expected to generate 20 terabits per second. In order for you to imagine this number, this is equivalent to 6.7 million homes simultaneously consuming HD videos, simultaneously streaming HD videos. So how do we typically transport such large data sets in research and education networks? In research and education networks, sites are typically connected over secure VPNs using large capacity interfaces, large capacity links. These large capacity links are even often bundled together to form large network pipes to be capable from transporting such huge data sets. When these links are bundled together, they are typically using what we call a link aggregation group, or a lag. This lag relies on hashing algorithms to be capable from distributing the traffic flows across the different links. The hashing algorithm uses the information included in the headers of these data packets. Like I mentioned earlier, the source IP address, destination IP address, ports, etc. And hashing algorithm, and that's why you can find in the research and education networks what we call data transfer nodes implemented at the endpoints. These data transfer nodes split large data sets into multiple TCP flows so that they can utilize the hashing algorithm to distribute the traffic across different links of a lag. Hashing actually works very well when we have thousands of flows, but hashing is inefficient when we have few flows. This is because few flows do not provide enough entropy to the hashing algorithm to select different links of the link aggregation group, or different links of the bundle of links. This has implications. So this can lead to link congestion, which will result into packet loss and consequently what we call the TCP backoff. In conclusion, all this leads to poor network utilization as well as low data transfer rates. So how to efficiently transport elephant flows or large data sets across research and education networks? A solution is, one of the solutions is FlexE, or Flexible Ethernet. FlexE also bonds Ethernet interfaces to form a FlexE group similar to the link aggregation group, similar to the lag. Yet, FlexE does not rely on hashing algorithms to distribute traffic across different links of the bundle. So, how does FlexE distribute traffic across different links of the FlexE group? FlexE introduces a new layer, a shim layer, between the Ethernet MAC layer and the Ethernet physical layer. This shim layer carves the Ethernet bit stream into equal-sized blocks. These equal-sized blocks are then distributed across the different links of the group using what we call the round-robin method, a simple round-robin method. This method ensures equal balancing of the packets across the different links of the Flex E group. You will notice now that blocks are distributed across the different interfaces of the Flex E group, irrespective of the flows that these packets belong to. So does this have any implications at the receiver side? So when blocks are distributed across the different interfaces of the Flex E group, this means that data blocks can arrive at different times at the receiver. Also, it can arrive unordered. So the receiver, the receiver router will have to place these blocks in what we call a DSQ buffer. This DSQ buffer compensates the difference between the fastest and the slowest optical paths of the Flex E group. But buffering can introduce delay. So we have to keep this buffer size at minimum. In order to do this, it is recommended that the different interfaces of the Flex E group to follow the same fiber path in order to make sure that the difference between the difference in propagation delay between the different optical paths is at minimum. A second recommendation is that these interfaces have to be using SFPs, optical pluggables, from the same vendor in order to make sure that the difference in processing latency is also minimum. And finally, if these SFPs are digital coherent optics, the ZR and the ZR Plus standard, it should select wavelengths that are adjacent to each other because the speed of light over fiber vary by wavelength. Now, let me summarize the key points which I've covered in this presentation. So first, elephant flows consume a significant amount of network capacity, significant amount of bandwidth. Typically, in research and education networks, we rely on link aggregation groups, LAGs, that bundles different interfaces to transport large data sets. LAGs, or link aggregation groups, rely on hashing algorithms to load balance the different flows across the links of a LAG. Yet hashing algorithms are inefficient in case we have few flows, few elephant flows. And that's why Flex E is a suitable solution, because it does not rely on hashing algorithms. It is still a bonding standard like the link aggregation group, yet it does not rely on hashing algorithms to distribute traffic across the different interfaces of the Flex E group. The Flex E introduces a new layer in the Ethernet between the Ethernet MAC and between the physical Ethernet layer. This layer is the shim layer. It carves the bit stream into blocks and distributes these blocks equally using simple round-robin method to ensure load balancing across the interfaces of the Flex E group. This brings me actually to the end of my presentation. Thank you for listening, and I'm available in case you have any questions.
Our next speaker is Mr. Agustín Formoso from RIPE NCC. Please.
Thanks everyone. Also, thanks the organizing committee for accepting this talk. It's an honor to be here. Also to be able to visit this beautiful country. And also thanks for the translators in the back for helping me keep up with the great content that's being presented. Just give the slides some seconds. Should I press? I work at RIPE-NCC. RIPE-NCC is one of 5 organizations in the world. We allocate IP addresses to different networks that want to connect to the internet. We cover the service region of Europe, Middle East, and parts of Central Asia. But we also do internet measurements. So this is what we can observe of the events happening in the internet. And one analysis we have been doing is around cable damage. So some of other presentations have been talking about how important cables are. We have this measurement platform, and we're curious what can we observe from our measurements. The work I'm going to present is the product of Emil Aben. He's one of our researchers. He's been presenting in different venues, and I'm doing a short version of this. So this is how the short story starts. This is the timeline of events. Somewhere around end of 2024 is when some conversation was happening about cables being disrupted in the Baltic Sea. And somewhere around January is when the second cable was restored. And that's the timeline I'm going to cover, and that's the 2 cables I'm going to talk about. The BCS East-West and the Sea Lion. And this affects 4 countries. It was Sweden, Germany, Latvia, and Lithuania. It has been all over the news. So lots of places have been covering this. So it only made this phenomena a little bit more difficult to understand, because on the one hand, the news outlets were saying, or at least speculating on the reasons for these damages. On the other hand, when talking with sovereign cable operators, they also tells us, hey, this is also part of our operations. This happens frequently, and we are prepared for this. So we took initiative and tried to check what was happening from our point of view. So let me introduce you to RIPE Atlas. It's one of our internet measurement platforms. Nowadays, it consists of around 30,000 probes which are connected. These are typically plugged in people's homes, so these connect from residential places, residential networks. But most importantly and relevant for this topic is anchors. Anchors are a special type of probe. These are typically racked units, sometimes with redundant power supply, usually connected to the core of the network. So they're not connected to access network, but closer to where the big part of the infrastructure is located. And we run a ton of daily measurements. Some are requested by the user, which we call user-defined, and some other just run automatically from day 0 when these devices are connected. I was telling you about anchors. They do many measurements, but at least there's one that is relevant for here, which is ping measurements. And this is just the time it takes for our vantage point to reach a target. So we measure what's called latency in the network. That is the time it takes to reach a host. And also we measure packet loss. This is the amount of packets that we have sent but haven't come back to us. High packet loss would indicate that something is going on in the network and the network is dropping packets. One important thing is also these anchors, because we have higher expectations of how well connected they are. We instruct a automatic mesh. So there's a mesh of measurements that is created automatically between every single pair of anchors. So anchors measure themselves continuously over time, and that is very important for this case study. In this case, on your right, you can see in orange the anchors that we picked to check if there was information or at least some nice data at the time that the cable cuts were reported. For example, between Rostock and Helsinki, you would expect that those pairs of anchors would be measuring each other and they would be able to provide a signal around the time of disruption. So that's a bit the anchor count. Usually the more nodes you have, the better. You have more certainty in the data you're working with. In the case of Lithuania, it's a little bit on the low end, but still it was able to provide some information on the events. So this is a bit how the measurements look like. On the x-axis, we have daytime around the time where events were reported. On the y-axis, so every row is a path between two of these anchors measuring each other. In orange, we have the latency values. So you can see that not a lot of rows were affected by high latency, just some of them. Also, there's a summary chart at the top that shows an aggregate view of how this was impactful in both latency and orange. You could see the step up clearly, and packet loss in black. And that's where things were reported pretty clearly. So just one note is these are not absolute values of latency, it's just the difference between what was considered a baseline before the events and the values afterwards. This is a little bit of zoom in into the upper chart. Also notice that you can see some small peaks in the black chart which represent the packet loss, but the difference between the pre-situation and the post-situation is not that big. So this was flagged as events not having a significant impact in packet loss. Similar situation for the other cable. That's where their reported damage was. You can see that there are more rows affected than in the previous case. You can also see there's a higher baseline level of packet loss, but also the difference between pre and post event was not really considerable. So the effect on packet loss itself was not big. In latency, as you can see, it was. So those were the events of the cable breakage. But we also observed the events of the cable repairs. So on the vertical line, the 1730 on 28th of November is when the cable was reported as repaired. But afterwards, we kept on seeing latency effects. Our speculation is, okay, some networks were probably using that cable, but when the events started happening, they chose to use alternate paths. So once the cable was repaired, they kept using alternate paths. And only once they were really sure, they started using the repaired network cable again. But that's a hypothesis. We don't have information or data on the cable layer itself. We only have from higher layers, so from the IP level. So we need to do some guesswork around the data we see. So this was using really simple ping measurements in which we can see latency increase, but we don't see packet loss increase. So what we call is the internet routes around damage. And the internet is like this graph of networks and how much can the internet tolerate when you start cutting links between those nodes. Service will degrade, but service will cope. So that's what we route around damage. We also did a deeper dive into this, not only using latency, but also taking into account the different paths that the measurements were taking. These are called trace route measurements and provide more rich information of what is going on under the hood. And we could basically classify networks in one of three types, depending on the level of resilience they have. And the first one is what we call inter-domain rerouting, and is my network was sending traffic through one, and in the time of events, I started sending traffic through another network. So that's the in-between network rerouting. That's why it's called inter-domain, inter-network rerouting. As a second category is my network is not relying on other network, but the paths that information takes inside my network, they change. So we see a change in the IP addresses that are used inside my network. And as a third one, we saw that some of the paths, so we didn't see any change in the IP addresses, but we saw that the service code. So we think that at a circuit level, there is some redundancy that we just cannot observe from the IP layer. So it's redundancy happening at a lower level in the cables themselves. Picking another use case. So this is around the Red Sea, probably closer to the region, September this year. And in this case, you can see a lot more rows affected at the time of disruption. The little chart, the little black line plot, which is the packet loss, this chart is a little bit misleading because those packet loss levels are actually quite high. It's the peak that happens right when the disruption starts is around 50%, which is a lot. So in this case, we see both impact in latency and in packet loss. So a little bit summing up, in the first two cases, the internet routed around damage. There's different levels of redundancy, but resilience is not guaranteed. So you can have impact in both, and you can have service disruptions depending on your resiliency level. That's why it's important for us to keep measuring and keep monitoring. And this is when I come back to the start of my presentation about having anchors which fire measurements automatically and are part of a mesh. We want to have measurements before the events happen and not be reactive and only have measurements when or after things are already going on. We are a neutral source of information. We're in charge of basically operating this platform, making sure the data is available to whoever wants to use it. This is an open data platform where coverage is key. And we are basically requesting, especially from those networks that are not covered by the Atlas platform, if they would like to be part of this network, please reach out. This region doesn't have a big coverage, so it would be really nice to get some more vantage points, just to let you know how important this is. When we are talking about the Red Sea, in this case, the observation, so the vantage points that are used here is between France and India, two places that you would think they're totally unrelated. Well, coverage in some parts of the world make a big impact when events happen on another part of the globe. So that's why we would really like for those networks that would like to be part of this network, please reach out. And one more thing before wrapping up is our RIPE Academic Cooperation Initiative. This is a travel support grant that allows those submissions that are accepted to have financial support to attend our meetings. In our meetings, you will be able to present your work, also network with other attendees, and learn a lot from the content that's presented in that space. We have SEE, Southeast Europe 14, coming up in Belgrade, and RIPE 92 in Edinburgh, May next year. We also have a mailing list where there's information you can check, so please look it up. if you have any research related to networking, you might be a good fit for this. Also, shout out to we have a blog, it's called Ripe Labs. We publish stuff like this, but we also accept contributions from other people that want to give their work larger visibility and have feedback on their work. So please, if you're working in this world of networking, consider submitting things to be published via Ripe Labs. And I think that's it for the time we have. I would love to receive comments or questions. I think we're too close to lunchtime for this.
Thank you very much. The next presentation will be in Arabic in case you want to use the headset. So ندعو الآن دكتور مذكور الأزهر من الجزائر من جامعة زويل. Please.
السلام عليكم. بسم الله الرحمن الرحيم. أود أن أشكر القائمين على المؤتمر للسماح لنا ولدعوتهم لنا بإلقاء هذه الورقة. ورقتي موصوفة بتصورات الخبراء لمتطلبات تفعيل التعاون العلمي العابر للحدود بين الدول العربية، دراسة باستخدام منهجية دلفيل. يشهد المشهد العلمي العالمي تحولات جذرية، حيث أصبح التعاون العلمي العابر للحدود ضرورة استراتيجية وليست خيارا ثانويا لتحقيق التقدم والتنمية المستدامة، خاصة في سياق الدول العربية التي تمتلك رصيدا هائلا من الطاقات البشرية تنتظر التفعيل. إن هذا التعاون يمثل محركا أساسيا للابتكار وتبادل المعرفة، ويسمح بتعظيم العائد من الاستثمار في البحث والتطوير وتجنب التكرار، مما يرتقي بالناتج العلمي العربي إلى مستويات تنافسية عالمية. على الرغم من الإمكانيات الهائلة والإرادة السياسية المعلنة للتكامل، يواجه تفعيل التعاون العلمي العربي تحديات بنيوية وهيكلية كبيرة. تتجلى في هذه التحديات في تباين الأنظمة الأكاديمية واختلاف أولويات التمويل البحثي والحواجز البيروقراطية، مما أدى إلى بقاء مستوى التعاون دون الطموح المأمول. ومع ذلك فإن عصر الرقمنة وتطورات التكنولوجيا المتسارعة كالذكاء الاصطناعي والمختبرات الافتراضية يقدم نافذة حقيقية لتجاوز هذه العقبات وبناء بنية تحتية رقمية موحدة للبحث العربي. تبرز هذه الدراسة لسد الفجوة المعرفية المتمثلة في ندرة الدراسات التي تقدم إطارا متكاملا وشاملا لمتطلبات التعاون، وغياب منهجية استشرافية تضمن تحقيق إجماع بين الخبراء وصناع القرار حول الأولويات الفعلية. إن الهدف هو تحويل الخطاب العام حول أهمية التعاون إلى خطط إجرائية قائمة على رؤية واضحة ومنهجية تضمن استدامة هذا التعاون وفعاليته. تساؤلنا البحث الرئيسي: ما هي أهم الآليات العملية ذات الأولوية لتفعيل التعاون العلمي بين الدول العربية؟ لنا 3 أهداف رئيسية لهذه الدراسة. هو رصد تصورات خبراء حول متطلبات تفعيل التعاون العلمي بين الدول العربية، تقديم تصنيف منهجي لمتطلبات تفعيل التعاون العلمي بين الدول العربية من وجهة نظر الخبراء، واقتراح إطار استراتيجي بآليات عملية متسلسلة لتعزيز التعاون العلمي بين الدول العربية. تكمن أهمية هذه الدراسة في الأهمية النظرية: إثراء الأدبيات العربية في مجال الدراسات الاستشرافية في مجال التعاون العلمي بناء على وجهات الخبراء الذين يعيشون التحديات ويعرفون الإمكانيات. شكرا. الأهمية العملية: يقدم هذا البحث إطار مرجعي بناء على رؤية الخبراء يعين القائمين على الشأن في تبني سياسات علمية عربية موحدة لتفعيل التعاون العلمي العربي. يعني بعد قراءة الكثير من الدراسات حول الموضوع أنها تجمع جل الدراسات على أن منظومة البحث العلمي في الدول العربية تعاني من تحديات هيكلية حادة أبرزها القصور الشديد في التمويل المخصص للبحث والتطوير وتشتت مصادره، إلى جانب هجرة الكفاءات وغياب الموائمة الفعالة بين التخصصات الأكاديمية واحتياجات سوق العمل. هذا بالإضافة إلى ضعف البنية التحتية للمختبرات موارد مؤهلة وتراجع مستوى التعاون العلمي الذي يظل شكليا ويفتقر إلى آليات منظمة لتبادل الخبرات والمعلومات، مع وجود تحديات إدارية وبيروقراطية تعيق المشاريع المشتركة. أبرز التوصيات التي جاءت في هذه الدراسات أن لتحويل البحث العلمي إلى رافعة للتنمية توصي الدراسات بضرورة زيادة وتنويع مصادر التمويل عبر إقامة شراكة حقيقية بين القطاعين العام والخاص، ووضع استراتيجيات وطنية وإقليمية واضحة وطويلة الأمد للتعاون، كما تشدد على ضرورة تعزيز التعاون المؤسسي بإنشاء مراكز بحوث مشتركة وتطوير منصات إلكترونية لتبادل المعرفة، مع ربط البحث بالواقع الاقتصادي والتركيز على المجالات ذات الأولوية الإقليمية كالأمن الغذائي والمائي وتبسيط الإجراءات الإدارية لتسهيل حركة الباحثين والمواد. وتنفرد الدراسة الحالية عن الدراسات السابقة تعتبر من الدراسات الأولى التي طبقت أسلوب دالفاي لاستشراف متطلبات تفعيل التعاون العلمي بين الدول العربية بشكل منهجي وشامل، لا يقتصر البحث على التشخيص فقط، بل يقدم حلول عملية ومصنفة حسب أولوياتها، مما يزيد من قيمته التطبيقية. توجيه السياسات يوجه البحث الحالي القائمين على الشأن العربي لتصميم مبادرات وبرامج تعاونية أكثر فعالة، وكذلك إشراك أصحاب المصلحة. أسلوب دالفاي بحد ذاته آلية لخلق شبكة من الخبراء وبناء التوافق بين آرائهم، مما يعزز فرص تنفيذ مخرجات البحث. تحليل الوضع الراهن يهدف إلى تقديم تقييم واقعي للتعاون العلمي العربي مع استعراض إنجازات والتحديات المؤسسية. يتسم التعاون العلمي العربي الراهن بأنه ممكن ولكنه غير مستدام، حيث لا يزال مستواه دون الطموح رغم وجود هيئات تنسيقية رسمية كبرى، تؤكد مؤشرات الإنتاج العلمي على ضعف الإنتاج المشترك بين الباحثين العرب مقارنة بنظيره مع الدول الغربية، مع هيمنة التعاون الثنائي المحدود على حساب التعاون الإقليمي الشامل، كما يعكس مؤشرات براءة الاختراع المشتركة المحدود جدا قصور في تحويل الأبحاث النظرية إلى مخرجات اقتصادية تطبيقية. وعلى الصعيد المؤسسي، ورغم جهود المنظمات الإقليمية كاليونسكو واتحاد مجالس البحث العلمي العربي في وضع الإطار العام، إلا أن تأثيرها يبقى محدودا بسبب تشتت الجهود وغياب منصة موحدة وفعالة لتبادل البيانات والخبرات. ويعد نقص التمويل المشترك والاعتماد على الميزانيات الوطنية المنفصلة بدلا من صناديق إقليمية عائقا ماليا أساسيا. وتضاف إلى ذلك التحديات الإجرائية والبنيوية المتمثلة في التباين التقني وصعوبة تنقل الباحثين، مما يوضح أن هذا التعاون يفتقر إلى بظلة هيكلية وتمويلية إلزامية لضمان استدامته. يوضح هذا التحليل أن التعاون العلمي العربي الحالي هو تعاون ممكن وغير مستدام، يتسم بالطابع المتقطع والافتقار إلى مظلة هيكلية وتمويلية إلزامية. هذا الفشل في التفعيل المستدام هو ما يبرر استخدام منهجية دالفاي للبحث عن إجماع الخبراء على متطلبات التغيير الجذري المقترحة في هذه الدراسة. دراسة تطبيقية. منهج البحث أن استخدمنا المنهج الوصفي حيث تم الاعتماد عليه بغرض التعرف على آراء مجموعة من الخبراء متطلبات تفعيل التعاون العلمي العربي. مجتمع البحث هو خبراء تم اختيارهم عمديا وليس مقصودا وليس عشوائيا. عينة البحث تمت على عينة البحث مجموعة من الأساتذة، إما محاضرين أو أساتذة التعليم العالي من عدة دول عربية لديهم الخبرة العلمية والعملية. مرت عملية انتقاء الخبراء في الدراسة الحالية بعدة خطوات كما يلي: إعداد قائمة مبدئية بالخبراء المحتملين وفقا للمعايير الانتقاء سبق تحديدها، دعوة هؤلاء الخبراء بواسطة بريد إلكتروني وقد اشتملت رسالة الدعوة على عدة عناصر هي التعريف بالدراسة وطبيعتها وأهدافها وتحديد طبيعة دور الخبراء المشاركين وما يتطلبه البحث من جولات، وأن أعداد الخبراء المشاركين بالفعل بجولات الدراسة الحالية بلغت 19 خبير قد استوفوا المعايير الكمية والنوعية المحددة سلفا، وقد أبدى هؤلاء الخبراء موافقتهم. أداة البحث. لتحقيق هذه هدف الدراسة قام الباحث بالاعتماد على جولتين في بناء الأداة. الأولى منها عبارة عن استفتاء مفتوح يحتوي على سؤال البحث وقدم الخبراء الجولة الثانية على شكل استفتاء مغلق تم تصميمه وتطويره من قبل البحث عن استجابات الخبراء في الجولة الأولى. الصدق الأداة ثبته إن منهجية أسلوب دلفي تؤكد على الصدق باعتبار تعدد مراحله وتركيزه على هدف الدراسة، ويعتبر معدل الصدق بهذا الأسلوب مرتفع جدا، وذلك لتعامل الباحث مباشرة مع الخبراء وإمكانية الاتصال المباشر بهم لفهم فقرات الأداة فهم سليم ودقيقا. أما بالنسبة للداتابيس تبين ذلك لاحقا ذكر نسبة الإجماع. الأساليب الإحصائية المستخدمة في البحث لتحقيق أهداف الدراسة وتحليل البيانات تم جمعها، وقد تم استخدام العديد من الأساليب الإحصائية باستخدام الحزم الإحصائية للعلوم الاجتماعية SPSS، وبعد ذلك تم حساب المقاييس الإحصائية التالية: التكرارات النسب المئوية، المتوسط حساب الانحدار المعياري للتعرف على الاستجابات، خبراء مشاركين تجاه المحاور الرئيسية التي تضمنها البحث. دراسة تطبيقية. سوف نعرف أسلوب دلفي بأنه طريقة منهجية للحصول على أحكام منظمة وتوافق في الآراء حول قضية معينة يتم الاعتماد فيها على مجموعة من الخبراء متخصصين لاستشراف صورة مستقبل ممكن أو المرغوب. يقوم هذا الأسلوب على التفاعل غير مباشر بين الخبراء عبر سلسلة من الاستبيانات متتالية الجولات والمعدة بعناية. العناصر والخطوات التي تحتاج إليها تطبيق أسلوب تتطلب خطوات تطبيق دلفي: تحديد الخبراء وبناء الاستبيان المفتوحة أو المقفلة، ثم إجراء مسوحات متكررة لآرائهم مع إخفاء هويتهم لضمان الموضوعية. العنصر الأساسي في المنهج هو استخدام التغذية الراجعة لتمكين الخبراء من إعادة تقييم آرائهم قديش مجال ممكن تم تجميع استجابات الخبراء وإعادة توليفها في 6 متطلبات هيكلية أساسية: المتطلبات الهيكلية المؤسساتية، المتطلبات القانونية والتشريعية، المتطلبات التقنية والبنية التحتية، المتطلبات المالية والتمويلية، المتطلبات البشرية والثقافية، متطلبات الأولويات البحثية. تمت تقريبا المصادقة بالإجماع على كل تلك المتطلبات الست. خلاصة عرض النتائج: بعد أن توصل الباحث إلى النتائج النهائية لآراء الخبراء عين الدراسة في الجولتين الأولى والثانية، قد أظهرت النتائج أن الإجابة على السؤال قد تم القيام بجولتين. الأولى التي تضمن السؤال المفتوح، وقام الباحث بمناقشة كل جولة على حدة، وكانت النتائج متعلقة بالجولتين كما يلي: موافقة الخبراء على تصنيف متطلبات 6 بدرجات مرتفعة جدا، اتفاق الخبراء على متطلبات 6 تفعيل التعاون العلمي بدرجة مرتفعة جدا، وبالتالي الهدف الأول والثاني للبحث قد حقق. رصد تصورات الخبراء حول متطلبات التفعيل، تم تصنيف منهجي تم تحقيقه بناء على اتفاق الخبراء على كفاءة المتطلبات الأساسية. وفي آخر الدراسة يعني قدمت هيك اقتراح، هو هيكل مقترح هو مظلة الجامعة التي تضمن التنسيق المؤسسي والتمويل المستدام. فيه 3 مجلس التوجيه، في الأمانة التنفيذية الدائمة، في الصندوق العربي للبحث والابتكار، ومن المؤسسة العلمية. المؤسسات العلمية دورها يتمثل في التنفيذ العملي للمشاريع. التوصيات الاستراتيجية: تم تقديم مجموعة من التوصيات لتحقيق وإنشاء هذا الهيكل. الدعوة لإنشاء المجلس الأعلى العربي للبحث العلمي والابتكار كهيئة جامعة، صياغة إطار تشريعي موحد، اعتماد آلية تمويل إلزامية موحدة، توقيع على اتفاقية عربية موحدة لتسهيل تنقل الباحثين، إطلاق مشروع عربي لتأسيس شبكة حواسيب بحثية فائقة ومنصة بيانات لتعزيز المشاركة الفورية في مخرجات البحث، إطلاق مشاريع أبحاث مشتركة في جميع المجالات. الخلاصة العامة: وعليه فإن تفعيل التعاون العلمي العربي مرهون بتحقيق المتطلبات الأساسية 6، ويعد الإصلاح المؤسسي والتشريعي المتوافق مع التمويل المستدام وتسهيل حركة الكفاءات هو العصب الرئيسي لتحقيق هذا التفعيل. وبهذا فإن البحث محاولة جادة لتقديم رؤية استشرافية متكاملة لتفعيل التعاون العلمي بين الدول العربية، ومن خلال تبني النموذج المقترح والعمل على تطبيقه بشكل تدريجي يمكن الدول العربية أن تحقق نقلة نوعية في مجال البحث العلمي المشترك، مما يسهم في بناء اقتصاد معرفي عربي متكامل وتحقيق التنمية المستدامة المنشودة. دراسات مقترحة هو إجراء دراسة مماثلة بنفس الأسلوب مع زيادة حجم العينة، إجراء دراسات مركزة حول كل متطلب على حدة مع زيادة حجم العينة ومراعاة اختصاصها ومتطلبات تفعيل الشراكة البحثية في الجامعات وقطاعات الإنتاج. قائمة المراجع. وختاما نشكركم على كرم الإسراء وآخر دعوانا الحمد لله رب العالمين وصلى الله على نبينا محمد آله وصحبه أجمعين والله أعلم. شكرا لكم.
Joining us virtually, I invite Mr. Joel Omiat from RENU. Is he connected? Yes? Mr. Joel, can you hear us?
Yes, please.
Yes.
Can you hear me?
Yes. Yeah, we can hear you very well. Please start, and you have the allocated 7 minutes. Thank you.
All right. Thank you so much. So I'll start now. Good afternoon, everyone. My name is Joel. I'm delighted to be here as one of the presenters. I work with the Research and Education Network for Uganda. And I'm honored to share with you the insights that we have gained in our efforts to promote digital inclusion using the eduroam service. So my topic today, the role of eduroam awareness campaigns in education and research, will speak to so many of us here who are working hard to bring connectivity to all. And as we move into an increasingly connected world, it's very important to ensure that no one is left behind, especially in the research and education community where seamless access to digital resources can change lives. So this is my outline. I won't dwell so much into this, we shall cover everything. Let me start by giving you a quick overview of what eduroam is and why it's very important. Eduroam, short for education roaming, is a secure worldwide roaming access service that has been developed for international research and education community, whereby it allows students, researchers, and staff at participating institutions to access the internet from any eduroam-enabled campus or location by simply using your institution's credentials. So this means someone from Uganda can travel to Jordan, can go to the UK, and connect to eduroam at any eduroam-enabled hotspot. So RENU's journey with eduroam has been marked by so many innovations and growth. And as you can see, our journey started with RENU's recognition as the seventh national roaming operator for eduroam. That was in 2016. Our evolution over the past 9 years has been remarkable. We transformed from a campus-only Wi-Fi to a city phenomenon, and later you being able to access it on the go. So between 2016 and 2020, as you can see on this slide, we only had 18 institutions on eduroam. And was still that's the time that COVID-19 hit. So students, researchers, and staff could not enjoy eduroam, which was by then an on-campus service. So what RENU did is we introduced Metro eduroam. Metro eduroam simply means eduroam within the city or outside the campuses of these institutions. So Metro eduroam was a solution to this internet challenges that our members face as their staff, their students, and researchers either worked or studied from home. So what we did is we extended 300 hotspots in different areas within the metropolitan area, but also later we expanded to different areas and cities. So the numbers of institutions on eduroam has kept growing, but also the team has continued to innovate. And as you can see, between 2020 and 2023, we had innovations like eduroam on the go. Eduroam on the go is a portable Wi-Fi device that allows users to access access eduroam anytime, whether you move or you just at home. And then also eduroam spot app, which helps users locate the nearest eduroam hotspot. Along the way, we also introduced the solar-powered routers, as you can see there on the image. Solar-powered routers have become an important solution, and it's still an important solution, especially in rural areas or hard-to-reach areas where electricity is unreliable. And these solar-powered routers make it easy and possible to deploy eduroam in off-grid areas. And currently, as you can see, we have 456 institutions on the network. So, despite the global reach of eduroam, these days almost every country has eduroam. Many institutions still face challenges with one, adoption and effective use. And a key reason for this is lack of awareness among the potential users. So I want you to imagine you having an access to a powerful tool, but not knowing how to use it. And even worse, you don't even know that it even exists. So this is the reality that hits so many institutions, hits so many students. They remain unaware of the benefits that eduroam comes with, and they don't know that they have a free, secure, and trusted internet access globally. And this underlines why eduroam awareness campaigns are not just helpful, but also very, very essential. So in 2021, the idea of the eduroam awareness campaign was born within us. Yes, the service was now available to institutions, but many students, many staff still didn't fully understand what eduroam offered. So we realized that for something like eduroam to fully transform how people connect, something like awareness needs to be done. So that's when the idea of eduroam awareness campaign was born. It was a spark, but very powerful, because we believed if people understood eduroam, they would use it. And in 2022, we took the idea and turned it into a real campaign where every month of September, which is our eduroam month, we dedicate it for our institution, where we go and run campaigns and engage users and help them connect to eduroam, and also just spread awareness. But like any other campaign, we had objectives in mind, and for us as RENU, the first objective is to increase awareness, which is very important. We wanted people to know about eduroam, what it is, how it works, and why it's very important. Once people are aware of the service, the next step is to ensure that they adopt it. It means getting them actively connect to the network, but also integrate it to their day-to-day activities. So adoption is key if you're looking at long-term success of your product or campaign. And then increase uptake on eduroam. RENU institutions are a key part of our network, and also increasing the number of institutions having eduroam also ensures a larger footprint. And this even makes the service more valuable for looking at students and staff who visit different campuses. And then increase visibility of eduroam brand. Eduroam here in Uganda is powered by RENU, and it's very important that end users recognize the connection between the two. This sort of strengthens also our position as a leader, providing seamless internet access across educational institutions. And then lastly, support digital inclusion, and by making something like eduroam accessible, we are helping bridge the digital divide whereby all students, all staff, regardless of their location or the resources that they have, can still access this free and secure and trusted internet. Yes, so we have a couple of strategies we use to drive campaigns, both physical and online. And we start with the online one. And you all agree with me that social media is one of the most powerful tools that we have right now. And it's still one of the powerful tools if we're looking at having campaigns like eduroam awareness campaigns. Why? Because this is where our primary target audience is, the students. So for us to truly reach them and engage them, we need to meet them where they spend most of their time. And it's on these platforms, but also with a tailored message. So we use platforms like X, Instagram, LinkedIn, YouTube, TikTok to broadcast our messages about eduroam. But also these platforms allow us to get a tailored message to different users. Because when you look at a platform like TikTok and YouTube, you're looking at the visuals, and also if you're looking at LinkedIn, you're looking at a more professional audience like the IT or the educators, which can implement eduroam within their campuses. And then also we use press release where we share different information across our social media platforms about eduroam. It could be partnerships, it could be rollouts or anything. We also create flyers, banners, motion graphics, and reels because we feel visual content is very effective when you're handling a campaign like a eduroam awareness campaign. Then also Twitter Spaces, which is now X Spaces, and then also we use social media influencers, and then lastly shoutouts. And then when you go to the physical campaign, this is when we are on ground at these institutions. And still you need to have a strategy if you want to have a great impact. So the first thing that we do is that we target the first year students. And usually they report around September and August. They are new at campus, but they are more likely to adopt eduroam as they settle in because they have courses that take up to like 2, 3, 4, 5 years. And then also we collaborate with the ICT and the guild team because they are like the ones in the process of students at campus when they need things like internet. So also if you're looking at the long impact, you need these people because usually our campaigns are for like 2 or 3 days, and after the campaign you need someone who still push the service like eduroam, and the IT heads and the students guild can help do that. We also use promotional items which we brand like branded books, t-shirts, wristbands, and flyers, and 360 booths, and then also spin and win, just to engage the students or the users when we are running out these campaigns. So the impact has been seen, and one of the most important results has been improved connectivity across these campuses. And because users now understand eduroam, they are using it more, and institutions are also exploring the coverage to meet the demand. And also we have seen growth in subscription on our social media platforms. As we share our eduroam content, engagement has grown, we have seen more people following us, we have seen more subscriptions, we have seen more interaction within our social media platforms. And it's important because it gives us a bigger audience to educate, it gives us a bigger audience to update, but also a bigger audience to support. And then also, thanks to our efforts, many institutions are now adopting eduroam as the primary or their sole SSID. And for us as RENU, this is a big deal because it shows how valuable eduroam has become within our member institutions. In fact, eduroam has become important that even if other competitors come and approach these institutions and they are trying to convince them to join them, the trust and reliability makes these institutions also think before crossing over. And then more engagement with activities, both physical and online, we are seeing more inquiries about eduroam, but also more usage, more feedback, and more participation from the students and the staff. And then finally, all these efforts lead to a national goal, which is bridging the digital divide. And by taking eduroam across these campuses, even off-grid areas with now our solar power routers, we are giving Ugandans access to a free, secure, and trusted internet that Yeah, so these are some of the institutions we have been for the physical campaigns since we started in 2022. And for this year, 2025, we went to 4 institutions, as you can see. And then this shows you how these institutions that I was showing you have been performing in terms of unique users. The difference is really big. These are institutions where we conducted campaigns in 2022. If you compare the number before the campaign and then after the campaign in 2024 and this year, 2025, you can see a very, very upward trend across these institutions.
Mr. Joel?
Yes.
We have to conclude. You're over the time, please.
All right, let me conclude a bit. And then this is how we have been performing in terms of unique users. And currently we have 133,000 unique users since 2023. And this is the number of institutions that we have currently, numbered being at 456. So these are some of the testimonials. I will just go into challenges if I conclude. The first challenges that we have experienced is budget limitations. We have a fixed budget for eduroam campaigns, which also restricts the number of promotional activities that we run during the awareness campaign. And then also, in many institutions, the number of students usually outweighs the number of RENU staff available on site. So during the campaigns, the staff often handles a large crowd, and there is a very high demand for support within a short time, which is usually 2 days. And then limited coverage. Some of these institutions do not fully have eduroam within their campuses, and it could be like blocks. So even when we connect students today, the coverage also affects them. But thanks to Metro eduroam, students can now enjoy and connect to eduroam in outside campus, in towns, hotels, cafes, and many more. And then also some devices not being compatible, which also frustrates users. And because if someone tries to connect today and it doesn't work, they will say the service doesn't work. But despite all this, we continue to find innovative solutions. We continue to support these institutions. So these are some of the pictures during the campaigns. And as I conclude, I would like to add other elements and also other educational institutions to take up a proactive approach in promoting eduroam through similar means like eduroam awareness campaign, because the benefits are far-reaching, not only in connecting students but also in creating a more digitally inclusive world. Our campaigns have shown how powerful targeted communication can be. And for us at RENU, we believe eduroam awareness campaigns are not just about creating awareness now. We are not only building and maintaining connections, but we're also working hard to bridge the barrier to access and make it faster and cheaper. Thank you so much.
Thank you very much for this insightful presentation. And as we announced yesterday, eduroam is here in Jordan and you can connect to it. So let's move to our final speaker, also virtually, before we move to the closing. Thank you very much for your patience.
Today's presentation will be about vehicular communication interference management with the help of reinforcement learning. Let me start by sharing the outline of today's presentation. I will start by sharing the context. Next, presenting the new system or the proposed system, which is based in the combination between V2X, 6G, and the configured intelligent surfaces. Next, system modeling, optimization problem, and the integration of the reinforcement learning, computer results, and conclusion. So, due to a huge increase of traffic density, which leads to accidents occurrence together with interference and information exchange complexity in the context of the communication among vehicles. In addition, we have another problem related, especially in urban zones. We have a blockage, which is a source of no line of sight communication. So for this reason, we propose in our paper the 6G as enabler for vehicular communication and reconfigure intelligent surfaces to overcome the problem of blockage in urban areas. And due to no convexity of the optimization problem, we propose reinforcement learning. So let's introduce first of all what is V2X communication. It is any communication between vehicles, whether it is with the infrastructure, pedestrian, vehicle to vehicle, or a vehicle to network. In our SIM, the adapted system is based on the use of 6G, which is based on terahertz communication, in which the spectrum is ranges between 100 gigahertz to 10 terahertz. So, but we note that there is another problem related to terahertz communication, which are the sensitivities of blockage. For this reason, we propose reconfigured intelligent surfaces to overcome or to allow virtual line of sight, which is mandatory for the communication between a vehicle. And here we have the system proposed, which is based in the combination between GNODB, RES, and a set of vehicles. We come now to the system model, which is represented by this way. We have the channel separating the RES and vehicle node, which is noted by H. We have a fast shift RES reflecting matrix. And we come up to the CNR, which is represented by this way, and the data rate, which is represented in function of the CNR. So the optimization problem is based on the maximization of data rate under the respect of or budget or maximum transmitted power, respecting a phase shift, which is ranged between 0 and 2p. So, and as we said before, due to the convexity of the optimization problem, we propose reinforcement learning as problem solver, which is based in Markov decision process, based in 3 pillars, such as action, state, and reward. The reward is the data rate that we have represented previously. So agent's policy determination is based in the learning process from the environment, in particular, which is the feedback of channel state information. And in addition, RES fast shift is selected through the already policy. We come now to computer results. We consider a vehicle travel with a velocity of 40 km per hour. The greedy policy is around 0.7. The maximum transmitted power is 23 dBm, and the receive factor is about 10, and the number of reflecting surface is 20. We come now to the computer results, which is the rewarding function of the episodes, showing the importance of the integration between reconfigured interference surfaces and vehicular communication system, as we have improvement in terms of reward. Now we come to the conclusion of the presentation. We have said that due to traffic density increase, which leads to the interference, so the focus of our paper is to manage the problem of the interference based in the combination between configured interference surfaces, 6G as enabler for vehicular communication, and the reinforcement learning in order to maximize the data rate under the respect of the RES fast shift and under the respect of the maximum transmitted power. So in the next research, we will consider our optimization, RES fast shift together with power allocation. Thank you for your attention, and for any question, please write me in my email, and I am so sorry for being online. Thank you so much.